Hi everyone, I'm Machos, UAV operator and 3D artist from F7 Digital in Germany. Today I am here at one of the most stunning cathedrals in Germany, Limburg Cathedral, to show you how to generate a 3D model using the latest DJI drone and its smart 3D capture features. This cathedral is over 800 years old. Unfortunately, it's showing signs of damage. Some areas even have to be covered to prevent falling debris. That's why I'm here, to capture high-resolution 3D model data for long-term monitoring. This will help track structural changes over time, such as crack progression or wear. The DJI M4E is a game changer, featuring 5-directional oblique capture and smart 3D capture. These features make data collection incredibly efficient. Let's get started. First, we generate a rough model. Go to the flight route and generate a new flight route using area route. And then check your goal on the map. Just tip here and here. This is our cathedral. And now we can, it's good to start to generate a rough model. Next, check, give it a name and use smart, oblique and local mapping. Then check the route altitude, let's say 90 meters, and save takeoff also. Check the side overlap and frontal overlay, 70 and 80%. Drone is taking up. Now the drone is moving to its start point. Everything is fully automatically from now. And then starting the task. You can switch from camera view. Now if you want to create a 3D model, select the Smart 3D capture function, and then you can find here the latest rough model we have created. We can see the rough model for the Limburg Tower. And now we refine our 3D model, selecting our 4 points again, and then set the altitude height. And now it's generating our 3D model flight route. Additionally, we can use the AR flight preview function to simulate the drone's flight path in the air, ensuring that it does not intersect with obstacles like towers, trees or building edges. For our close-range photogrammetry mission, we are configuring to operate with the avoid setting for obstacle avoidance. This will enable the drone to intelligently navigate around obstacles rather than stopping abruptly, ensuring smoother and more efficient flight paths. Now restart the main flight mission. The drone follows the optimized path and captures high-resolution images. Throughout the flight, I need to closely monitor the camera view and the vision assist view to ensure the flight safety. With our outer data collection complete, we move to importing the data into DJI Terra. In DJI Terra, I select 3D reconstruction mode, import the image data and configure settings. For high accuracy results, I use high precision mode. It's also essential to match the coordinate system with our ground control points, such as WGS84 or a local reference system. After obtaining arrow triangulation, we now proceed with selecting the input file format and other necessary operations like OBJ, LAS and so on. Once all parameters are confirmed, DJI Terra reconstructs the model automatically. Now we generate a final model. Using Terra's tools, I can highlight problem areas, measure structural components and extract necessary data. This step is crucial for identifying cracks or deformations, which can then be marked for further analysis. With a comprehensive evaluation of reconstruction accuracy, ensuring the reliability of the final output. Key information included in this quality report here. Engineers and general all users should pay close attention to the error metrics and feature point quality in the report to optimize flight planning or parameter adjustments, ultimately improving reconstruction accuracy. Always make sure none of your data is missing or corrupted. And that's it. With the DJI M4e and DJI Terra, we've created a highly accurate 3D model of Limburg Cathedral. This technology is essential for preserving historical landmarks.